In the present discussion, we have been talking about topics such as centroid, center of mass, center of gravity, and in specific, we started looking at the topic of locating centroid of plane figure. We have seen that if the plane figure has an axis of symmetry, centroid must lie on that axis of symmetry. And in fact, if we can identify two axes of symmetry, the centroid must lie at point of intersection of those two axes of symmetry. Okay, that is one method. Another method we have seen is to practically find out by using plumb line method. Okay. These are two methods of identifying centroid. But what if an object does not have an axis of symmetry? What will we do then? That is the question we'll try to answer in the present discussion by proposing a mathematical framework for locating centroid. Consider a plane area something like this, an irregular shape. Okay, and let us say we want to find its centroid. Okay, let me hatch it to show that we are concerned about the area enclosed by the boundary. This is the area that we are considering to locate the centroid of it. Okay. When we say we want to locate the centroid of this, centroid is a point. That point typically is represented by symbol G. If you have several objects, you will have G1 as the center of centroid of object 1, G2 as the centroid of object 2, and so on. When we say we want to find the centroid of it, what we really mean is we have an x and y axis in mind. You have x-axis here, you have x-axis and y-axis. Let us say this is x and this is y-axis. We want to be able to find the coordinates of this point G. That is what we mean when we say we are interested in finding the centroid. So we are interested in finding what is the x coordinate of this point. X coordinate is given by this distance, and typically this x coordinate is represented by x bar, and this is the y coordinate. This height is the y coordinate, and this is represented by y bar. So when we want to locate centroid, we are interested in finding its x coordinate and y coordinate. Keeping this in view, we'll try to propose the mathematical framework for computing the values of x bar and y bar. This we will do by first identifying what is the leftmost point on the boundary, what is the rightmost point on the boundary. This we do to find out the limits of integrations that we are going to write down. So the limits will be from XL, from the leftmost point, to rightmost point as given by XR. Okay, and then we will consider a thin strip of material. Let us say this is the thin strip of material. Let me draw it real quick. This strip of material we assume is at a distance of x, so we consider it center point, and the center point we say is at a distance of x, and we will say that its thickness given by this dimension, its thickness is delta x, and we will say its height as given by this is y. Okay, it takes a little bit of time. Its height is given by y. This area, center of which is located at a distance of x, which has a height of y and a thickness of delta x, is called an elemental area. We will be considering several such elemental areas at varying distances. At x1 you have an elemental area of area A1. At a distance of x2 you consider another elemental area A2, and so on. We repeat the process for all values of x between xl and xr. Let us designate this elemental area at a distance of x and a height of whatever y is dA. With this understanding, we write an expression for the x coordinate of the centroid, represented by x with a dash on the head. We read it as x bar, as integral between the limits xl and xr, x times dA, and within the same limits integral dA. Okay. Once again, let us look at the terms. This x is the center of the elemental area, dA is the elemental area, xl is the leftmost point on the boundary of the object, xr is the rightmost point on the boundary of the object. Note here two things. To find out what is the x coordinate of centroid of this plane figure, we took an elemental area which is perpendicular to x-axis. That is one important thing that you need to remember. And second thing you need to kind of appreciate is the approximation that we take. For example, this area is not exactly rectangular. You have a little curved portion here and you have a little curved portion here. We ignore that and we say this is a rectangle of height y and thickness dx. So this y we approximately write, very strictly we need to write approximately, is y times delta x. Okay. With this kind of framework, we are now ready to find out what is the x coordinate of the centroid of a geometric figure. If we come back a little bit, let us see what we have done. We wanted to find what is the centroid of the plane figure given by this area. And when we say we want to locate the centroid of this plane figure, we really want to find out what is the x coordinate of the centroid, what is the y coordinate. This is what we want to determine and compute. To do that, the first thing we did is we established a x-y axis with a well-defined origin. This we may choose at a convenient location. Then we identified what are the limits of integration. This xl is the leftmost point, xr is the rightmost point. You identify the leftmost points x coordinate, leftmost points x coordinate, and x coordinate of the rightmost point, and we use them as limits of integration. Then we consider an elemental area, center of which is at a distance of x, whose height is y, and we do the integration, integral x dA by integral dA, to compute the x coordinate. While doing that, we will assume that this elemental area is rectangular. We ignore the curvature of the end sides, and we write that area is y dx. Note here that when we want to find x coordinate of the centroid, the elemental area considered is perpendicular to x-axis. Similarly, when we want to find the y coordinate of the centroid of this plane figure, the elemental area we consider will be perpendicular to y-axis. We'll see a little example here. We'll take a very simple geometric figure. that is a rectangle, and try to see whether this gives the expected centroid. Let us say that the rectangle that we want to consider has a base of B as shown here and a height of H. So the first thing that we want to do to find the centroid of this plane figure is identify X and Y axis. Let us do that. Let us say our X and Y axis are identified as here, X and Y as given there. Now we will see that the leftmost point is located over here, and so your X coordinate of the leftmost point is given to be 0, and rightmost point is located over here at a distance of B from the Y axis, and so your XR is given to be B. So your limits of integration are from 0 to B. With this we consider a elemental area, because we are trying to find X coordinate of this plane figure. We consider the elemental area perpendicular to X-axis. Having established the X-axis, Y-axis, having identified XL and XR to be 0 and B, we consider the elemental area as shown over here. This is the elemental area. Center of the elemental area is just somewhere over there, and we write the formula for the centroid, X coordinate of the centroid. X coordinate of the centroid is integral 0 to B X times dA divided by integral 0 to B dA. Because the elemental area itself is perfectly rectangular, this edge is straight, this edge is straight as shown over here. This delta X we write as the differential dx. With this understanding, the elemental area dA may be written as h dx. H is one side of this elemental area, dx is another side of this elemental area. With this understanding, we will write the integral for finding x bar as. Having said that this dA is really h times dx, we substitute that h times dx in place of dA, that is, this is integral x times dA divided by integral dA. Okay. H being a constant, we take it out, and integral of x is x square over 2. So this expression really comes out to be x square over 2 between b and 0, x between b and 0. If we simplify, we will get this as the numerator comes out to be h times b square over 2, and the denominator comes out to be hb. Note here that this quantity hb, which is integral of x dA, integral of dA between the limits 0 and b, is the area of the rectangle, which is h times b. So note that whatever is in the denominator is the area of the whole geometric area. In this case, it is the area of the rectangle. Thus, we have x coordinate of centroid of the rectangle with x and y axis taken as shown there is b over 2. That is, your centroid lies at a distance of half the base from the height. Let us quickly try to write what is y bar and wind up this lesson. To find the y coordinate of the centroid of the rectangle, the same rectangle is shown over here, bounded by the 4 points, and the x and y axis we have taken just as we have done in the previous case, and identify the element which is perpendicular to the y-axis. When we want to find the y-coordinate of centroid, we take the elemental area to be perpendicular to the y-axis. Having said that, we note its lower limit is 0 because the lowest point is given over here. The uppermost point is given over here. So this YL is 0, Y uppermost is H. So your limits of integration are from 0 to H everywhere. With this, we write the formula for y bar as integral y dA. Recall that in the previous case, when we want to find x coordinate, you have x dA. When we want to find y coordinate, you have y dA. You evaluate this integral, noting that this dA is really b times dy as shown over here, and get the location of centroid as at a distance of h over 2 from x-axis. So if you want to recall what we have seen so far, we will try to review. Given an area for which we want to locate the centroid, when we say we want to locate the centroid, we want to find out what is the value of x bar and y bar. The moment you say you want to find out what is the x coordinate and y coordinate, you need to establish an x-axis and a y-axis along with an origin over here. And when we want to find out the centroid of x coordinate of the centroid, we consider the elemental area to be perpendicular to x-axis, and when we want to find out the y coordinate of the centroid, we will consider an element perpendicular to the y-axis. Okay, and the integrals and the formulae for finding x bar and y bar are shown over here. I would encourage you to go through the example for finding the centroid of a rectangle as given over here. We will try to solve several more problems, and then we go to the next topic, that is how to find the x and y coordinates of the centroids of figures which are made out of several primitives.